In this video, we're going to begin to look at different peptides, or rather peptide diversity. Now, when we talk about peptides, which again are just amino acids that are connected, we have different levels of structure we can talk about them. And we start with primary structure, which we call 1'. And primary sequence or primary structure is simply the sequence of amino acids N-terminal to C-terminal. That's how we name the amino acids. Now, if we think about all the possible amino acids that we could have, and let's say we are thinking about how many different 100 residue amino acid peptides could we make? Well, the math of that is 20 raised to the power of 100, which is 1.27 times 10 to the 130, which is probably more atoms in the universe. Now, obviously, we don't have that many proteins in nature. We actually see only a very, very, very small percentage of these proteins in nature. Now, when we talk about proteins in general, if we label something, a peptide as a protein, it usually has 40 amino acids or more. This isn't a rule, it's just kind of a rule of thumb. Anything less than 40 we call a peptide. Anything more than 40 amino acids we call a protein. And proteins can have multiple subunits. Which a subunit is basically a polypeptide chain. So proteins can have more than one peptide chain in it. You can also make proteins that are synthesized as one complete subunit and then chopped up later to have multiple subunits. So insulin is actually created as one long peptide chain. And then after it's created, it is chopped up to create a protein that now has multiple peptide chains. And if you look at all the proteins in the body, the vast majority are between 100 to 1,000 amino acids. And the thought for that is greater than 40 is needed for a three-dimensional structure to form. While if you are trying to create a protein greater than 1,000, the idea is that your ribozymes are not that efficient. Rather, their efficiency tops off at 1,000. Again, this is all hypothesis driven. And here we can just look at some proteins we have on Earth. The biggest protein we know of is Titin. We have the mouse version here. It's also found in humans. That comes in a whopping 35,000 amino acids. And strangely enough, it's one subunit. So who knows how efficient ribozymes might actually be if it can pump out an amino acid that's 35,000. While compare that with glutamine synthase, which is 5,000 amino acids but 12 subunits, which is telling us each subunit is less than 1,000 amino acids probably. And that's it for this video. I will see you in the next video.